So thank you for being here. And thank you to Proteum, one of our major partner in distributing our product, to give me the opportunity to give you a glance about what is the IMO 3 compliant engine. You will see in this type of engines, which is maybe smaller than the big ships, we all adopt, all the OEM, we all adopt the same technology, meaning the SCR technology. Yes, so an introduction to an IMO 3 and EPA 4 solution. Also EPA 4 because it was the trigger. EPA is the regulation in the US. And it was the trigger of this project, of this new product development, because it came in force, let's say, a little bit before the IMO 3. So I will be brief, but I will give you some information about Baudouin, who we are, for those who don't know us. We will go very briefly because we had a good information about IMO 3, what is IMO 3, and then we will go through the SCR technology, the engine that we are using. We will talk about SCR, but there is also an engine, and then a little bit more in details, and I hope for you with some useful information about the SCR, how it works, but also how it is installed, how it is operated, and so on. Let's start with Moteurs Baudouin, who we are. We are a French engine manufacturer, providing marine engines for propulsion, marine generator sets, and since 2 years also industrial power generation engines. Moteurs Baudouin exists since 100 years. We celebrate last week the 100th anniversary in Marseille. We are located in the south of France. And I think today we are the only marine engine manufacturer that is designing for marine purpose. Main of our competitor, they are designing engines for railway, industrial trucks, and are doing manualization. We are designing engines since 100 years for marine purpose. As said, propulsion engines, generator sets, but we are also providing and we are support the installation. We have dedicated team for that helps the customer, that helps the shipyards also to work on the interface and to install the engines, meaning also the complete propulsion system definition with the gearboxes, the line shaft, the propeller, and now also exhaust after treatment to be compliant with the last regulations. A part of this, of course, the complete package, meaning the silencer, the couplings, and as said, some tailor-made solution possibilities. So this is Baudouin with a range of engine going from 100 kilowatt up to 1214 kilowatt. Here this is HP, so from 110 up to 1650 HP in propulsion. About 12 engines to cover this power bandwidth. The marine generating sets also starting with 85 kVA as prime power up to 1091, yes, kVA with our 12-cylinder engine. So far for Baudouin, who we are since 100 years. I will go really rapidly because we had all informations. You know now that IMO 3 is in force since 2016. Mainly in the US, in the North America, and it will come here, the new ECA in 2021 for all engines in the north of Europe. I think the rest of the world will remain, of course, IMO 2, and it will, of course, also represent the largest, the biggest market until that. I think I can pass rapidly on this. We already had it. EPA Tier 4, this maybe not concerns all of you. It's only for USA, inland, and also all the coast, where EPA 4 is also regulating not only the NOx, but also the hydrocarbons, the particulate matters, and the CO, the carbon monoxide. Only for engines above 600 kilowatt. So, what is SCR? We, in order to comply with these new regulations, we adopt, as mostly all of our competitors in this engine range, the SCR, Selective Catalyst Reduction. It's an exhaust gas after treatment, only for NOx emission. Some of the cars today with the Euro 6 are already equipped with the SCR technology, so maybe you have already heard this. It's a continuous process. It's not a trap, like a particulate filter, like that you also have in your car maybe since some years. And it's based on injecting, dosing, we call it dosing, a reducing agent, urea actually, in the exhaust, and urea will react with the NOx that we want to kill in a catalyst. There are many technologies to fight against NOx, and depending the size of engines, you maybe heard about fuel water emulsion, about EGR, all these things. SCR today is the technology that is capable to reduce above 90% of the NOx emissions. And as said, automotive and all in this engine range, this is of course the most efficient technology today. SCR is not just, it's not, I call it plug and play. We can take, maybe you have heard that some supplier can propose SCR to put after an engine, but the efficiency will be less. You will see that engine and SCR have to match. And we had to rework a little bit the engine that we have today in order to have the best efficiency of the SCR. You can take an SCR from the shelf, but the engine will not be working well. The fuel consumption may be degraded, and the SCR will have only an efficiency of 60–70%. Retrofit is possible, and it's now a proven technology in the marine sector, especially in big boats. It has been applied since years. SCR actually is a technology that is 40 years old, mainly used in the industry, and then now since 10 years in the truck, in the automotive sector. Okay? How it works? Rapidly, I will not go into the chemical process. Anyway, I forgot the formulas. We got the NOx that is coming from the engine, which is NO and O2. These NOx are going through, or they are passing in front of a NOx sensor that is determining how many NOx emission is coming from the engine, giving the signal to the controller in order to inject what we said, this urea-based solution. Maybe you have heard AdBlue is the generic word for this. So we are injecting urea, I'm sorry. And this urea will, through the action of the heat and the water in the exhaust, here will give NH3, ammonia. And this NH3 is then chemically reacting in the catalyst with the NOx in order to give clean exhaust and water. We need the catalyst in order to catalyze the chemical reaction between ammonia and the NOx. Of course, after that, we have also a NOx sensor. So far for how it works, what is SCR. I will stop here. But that means that we need two things. We need a catalyst system, catalyst in its housing, and we need what we call a dosing system that maybe also interests you in terms of installation, meaning we need a tank for the urea, we need some urea pipes to bring the urea to the injector, a pump, a controller, an injector, let's call it dosing module, and of course some sensor to monitor and to govern the injection in the exhaust gas. So far clear for you? Okay, thank you. As said, we applied this technology to the two new engines that we launched 2 years ago, because we took also, as it has been right said, we took our new electronic controlled engine. SCR can maybe work with the mechanical engine. We tried, we failed. But it has to work with the common rail engine to be as efficient as possible. So we took our 6M26.3, which is the 6-cylinder we launched 2 years ago, with this main characteristic. It's a 6-in-line, a common rail, and today IMO 2. Now it's also IMO 3 thanks to the SCR, and we propose this to the market from continuous duty up to intermediate duty with the rating that are listed here on the screen. The big brother is the 12-cylinder with the power from 883 as a continuous duty up to 1214 kilowatts. As said, it's not only a plug and play, the SCR, so we had to rework a little bit the engine, meaning we changed the piston, we optimized the combustion chamber with another injector, another turbocharging. Why? Because we wanted not only to fight the NOx, but also the particulate matters, so we had to rework the combustion chamber. Some features about these engines: easy maintenance. As said, we are designing engines for the marine purpose. Crankcase door, filter on front with the easy maintenance. A very low life cycle compared to our competitors today with this engine also, the M26.3. Adapted performance, we tried also for the SCR to have, with one engine, the possibility to go from fishing to yachting market just by adjusting the calibration and the performance. And some features, I put one here, where we are really concerned about is the safety on sea with a 4-step engine control redundancy that ensure that whatever happens, you can go home safely. This is our reference today with this engine, from fishing to yachting. One of our biggest success is the water taxi in New York City, where we could supply many engines for the Hornblower company. Also, one important project was the Carlin boat, the wind farm supply vessel that is working in Holland today. And other application with Damen and the Turkish defense army. Okay, so far for the engine. Let's go now a little bit in detail in the M26 engine with the SCR. We took, here it is the 12, our M26.3. We changed a little bit the combustion, of course, the calibration, and we applied an SCR in the exhaust line of this. Here we find again how it works. We have the NO and the NOx that is coming out of the engine. We are dosing, and at the end we have to 90–95% a clean, a NOx clean exhaust. This is how the engine with the SCR is looking with the different view. You see that on the 12 we have 2 SCR, one for each bank. And for the 6, we have the same. We have a modular product that is working for the 6 and the 12. We have just 2 for the V12 for each bank. What are the key points of our solution, knowing that the biggest challenge for this technology, when you are doing it for the car or for the truck, you are designing one time, it's produced 10,000 times, it's okay. Here we had to find a solution that will fit to all the engine room possible. The fishing, you know better than me, that the engine room becomes more and more smaller, and we had to find a solution that fits to all types of engine room, all size of engine room. That's why we worked a lot of the volume and the compactness of this solution. This was one feedback on the SMM or on the ITS show, that we could reach, even if it looks larger on the picture, I agree, but today we are one of the smallest, or the smallest on the market on this. We try to integrate the design of the SCR into the design of the engine. The second key point is the modularity. That will give us flexibility in the installation. We will see for the SCR catalyst, but also for the dosing system. And we try to make it compatible with all type of application. The efficiency, as said, we are able to reach 90% NOx reduction, and also we achieve to decrease particulate and fuel consumption. How? Through the combustion, we work the combustion to reduce the fuel consumption. Of course, this increases the NOx emission on the other side. It's a trade-off, and the NOx are then treated with the SCR afterwards. These are some data. Important here is to see how our SCR is made. We have the inlet cone. We have then what we call the mixing box. This is where the urea is injected and where it's mixed and to come into the reactor. This is an important part, and this cannot be dissociated, the mixing box and the reactor, because here we have to ensure that urea is well distributed on the catalyst and is well mixed with the NOx in order to react on the catalyst itself. Modularity. We are proposing first 2 types of orientation, either over the gear, over the engine, as you see, the configuration number 1, or above over the gearbox. We can also propose to have the SCR as, how do we call it, standalone, that you can put the SCR wherever you want in the engine room, if you are respecting some conditions, some boundary condition, especially the temperature, the exhaust temperature. Why? The chemical reactions are only working between 200 and 500 degrees. This is why I meant that a mechanical engine that you cannot adjust for the temperature is the right engine to work with an SCR. Maybe you will degrade the fuel consumption, or you will not have the right temperature to ensure the reaction. So we can propose this 3 configuration, and then also between the mixing box and the reactor, we try to make something modular that fits. I showed an installation that we made in Thailand, where we try to play with the different configuration. I have a video at the end of my speech to show you that we can play with the orientation of mixing box and reactor. Flexibility. Our partner, Tenneco, who is one of the leaders in the after-treatment system business, we did not, as other made, we didn't take a system that is coming from the automotive or the truck industry. We take something that comes from the large vessel. That means that we have some flexibility, and especially in the distance that we can put between the engine, the tank, and the cabinet where is the pump, and also the height, we have some flexibility for you to install the whole system. Compared to some of competitor, our system is airless. That means we don't need additional installation to supply the urea. Efficiency. Here I put the results of our last official test, meaning that we are complying today with the IMO, but also the EPA, as said, the EPA Tier 4 for the V12. We could reduce the particulate matters in the combustion as raw emission. We could reduce also the fuel consumption. As said, this increased the NOx emission, but we don't care. We have the SCR today. And this is why we could achieve to reduce around 2 to 4% the fuel consumption compared to the actual engine. Another feature of the SCR is also that it has a silencer function, with today a sound attenuation around 23-25 dB. If you need more, you can put a silencer behind. But today, we could achieve this. That means you don't have to install additionally. This is already quite big. You don't need to install additionally another silencer. Rapidly, what's the hydraulic architecture of an engine with an SCR? You need a tank, you need pipes, the urea filter, and then we have the control box, where inside you will have the pump, you will have the controller, some wiring, and also the emergency button and some signal lamps. Then you will have what we call the CRM, which is actually only a device that splits on the two bank the urea, and at the end the urea injector, or let's call it the dosing module, one per bank for the V12. That is dosing, injecting the urea, the ammonia into the exhaust. Of course, as said previously, we have temperature sensor. We need to ensure that we activate the SCR only when we are above 200 degrees, and temperature sensor behind, because the SCR above 550, 600 degrees, it will have some damage because of too hot exhaust. We have a differential pressure sensor to monitor, of course, the back pressure in case the SCR will clog. This is one of the main focus we had during the development, because we know it could happen in the past that urea is, maybe you've heard it, crystallizing into the exhaust because of the wrong dosing, a wrong temperature, and this will clog the SCR. So we could achieve the design. We spent a lot of time, a lot of simulation in order to avoid that we have this crystallization effect from the urea. Anyway, we put a differential pressure sensor to monitor this. So this is what I just said. Additionally, you will have in the tank a sensor that has the function of urea temperature, the urea level, but because it's asked by the regulation, especially by the EPA, to monitor the quality of the urea. Because maybe one of the questions could be, what happens if I put water or whatever in the urea tank? It has a cost, the urea. It will not work. We will detect it, the chemical reaction, of course not, but we will not dose because we are asked to monitor the quality of the urea in the tank. About the tank. The tank, we are not supplying the tank, but we are here to recommend and to help into the dimensioning and the shape of the tank. The urea consumption, depending on load, depending on what application, is representing approximately 2 to 5% of the fuel consumption. We always recommend to have a tank that is representing 6 to 8% of the fuel tank. But this depends. If you want to have a bigger or smaller frequency of refueling urea, this is at your discretion. Material of the tank has to be urea resistant, of course, and we are recommending the stainless steel in accordance. There are already some regulation on this, and the IAX, the certification society, has already written some recommendation on this. Same for urea line. We will not supply it. The shipyard will design and provide himself under our recommendation. It may be, but maybe for very cold application in the Arctic Sea, that we need heated urea lines. This is the case in the automotive because urea is freezing at minus 11. So in the automotive, for example, the urea lines are heated to prevent the freezing. In the engine room, minus 11, it's maybe not so common. About installation, how do we install this big 200 kilogram heavy SCR into the engine room? Different possibilities. We designed some frame that we can propose, of course, and we designed also some fixing point with bracket to install it on the roof. As said, thanks to this modularity, we can play with the orientation of the component, the mixing box and the reactor, in order to have more space for the rest in the engine room. For this, I know many of you are naval architect or shipyard. And you will have it on the USB key that Ellen distributed. You will have the 3D models of the SCR, of the engine and of the SCR, but we split it so you can play with the orientation in order to install the SCR as you want, as you can in the engine room. So the step model are on the USB key. During operation, how it works? SCR is activated automatically. That means the system is on, but we are waiting, of course, that we have an exhaust temperature above 200 degrees, that all the hardware check is okay to start to dose. So maybe one of the questions could be also, because in the automotive is like this, what happens if we are running out of the AdBlue, the urea? You know, in the car, after 3 start attempt, you cannot start anymore. Don't worry, we are not doing this. We are on the sea, so there will be no shutdown, no engine derating, of course, but an alarm will raise, and it will be written in the logbook in order that, especially the EPA agency, will see that you are running without urea. But on the engine operation, it will have no consequence. Of course, if something happens, or let's say if you need to shut down the SCR manually, of course, you can do it on the system. Something important also, that the engine performance are not altered by the SCR. We have some counter pressure, a little bit more counter pressure, of course, but we could compensate this during the development. I think we will talk about fuel in the next session. Here we need to take care to run with the EN 590 fuel, the off-road fuel, the standard today, because also sulfur, the sulfur content must remain under 15 ppm. Sulfur is poisoning the catalyst, and the chemical reaction will not happen anymore if the poisoning by sulfur is reaching a certain level. In terms of cost, the running cost, that could also be a good question. Today we estimate at 5 to 7 euro per megawatt. Operation and maintenance, the cost of an SCR. That's why also we focus really to decrease the fuel consumption in order to compensate this additional cost for the owner, for the operator. We just talk about the maintenance. Maintenance of the catalyst is quite easy, meaning normally one time per year, just by washing, blowing the catalyst, the reactor, maybe some soot, maybe some deposit can happen. There will be, on our system, a maintenance door to clean it. But the catalyst anyway has a lifetime today between 12,000 and 50,000 hours, depending on the application. Injector, filter, this, they have a smaller lifetime, of course, between 1,500 for the filter and 5,000 hours for the injector, the dosing module, and the gasket. The pump, which is also the core of the system, has a lifetime of 20,000 hours. So to finish, just to show you two references we had on the SCR. This is one boat we are commissioning today, actually. Got the email from the engineers. They are on site. It's in Thailand. The passenger ferry will be operated in the Virgin Islands next year. And this is where we installed two V12 as a intermittent duty with 1100 kilowatt. And you can see here with the SCR installed on the roof of the engine room, where also here you see that they played with the orientation of the reactor. And as said, normally next week it will start to run. And this is another very important project where we are working with INCAT in the US for the EPA4 this time. It's to complete the fleet of the Hornblower water taxi in New York, where we will install per boat. We have 6 boats to equip. We will install two 12-cylinder also, with the SCR in the engine room as it is shown on the picture on the right side. So this is expected to be built next year, and we are expecting more projects, especially also for generating sets with our six-cylinder engines. That's all for me. Thank you.